Assalamu alaikum. Hi everyone. This is another video in the series of video lesson on the finite state machine. In this lesson, I bring in an example on the design of a counter with irregular sequence. Perhaps you are already familiar with the counter that counts through the natural sequence, that is 0, 1, 2, 3 and so on, and then repeat itself. But in this particular example, the sequence is rather non-ordinary, such that the sequence is 0, 2, 3, 5, 6 and repeats. I purposely bring in this counter example because it is a good topic to start understanding the design process of finite state machines. Indeed, it is a good topic to understand the concepts of states, including the used states and unused states, the external inputs, the outputs, the difference between states and outputs, and so on. All right, let's consider a few important points before begin with the counter design. This is the state transition diagram, or is simply known as the state diagram, which describes the transition of one state to another. As can be seen in the diagram, the counter counts through the sequence 0, 2, 3, 5, 6, and 0 and repeats. Here are a few important questions that need to be asked before we proceed with the circuit design. So these questions should be pondered. First, how many states, and then how many bits are used for state encoding, and then the next is what is the external input and how many bits it is, and what is the output and how many bits it is. There could be more questions if the system is more complex. All right, let's go through the questions one by one. First, how many states? Obviously, there are 5 states, 0, 2, 3, 5, 6. Actually, the first and the second questions are related in the sense that the number of states decides the number of bits that is required for the state encoding. So 5 states. All right, next, how many bits are used for state encoding? Let me rewrite this. So we have 5 states. How many bits are used for state encoding? All right, the keyword here is the state encoding, or sometimes is known as the state assignment. You know that when you want to implement a system as digital, every quantity or element must be translated into binary values. In finite state machine, there are 3 important elements. That is the input, the state, and the output. It is easy to understand that the input and output must be assigned as binary values so that they can be processed by the logic devices, as been done in the combinational logic circuits like the adder and multiplier. The state, on the other hand, is more abstract. A state tells the situation that's happening in the system, or the status or the progress of the process. Originally, a state is not a value, but for implementation, states need to be quantified. So back to the questions. How many bits are used for state encoding? If we have 4 states, we can use 2 bits to encode the states, such as if we have 4 states like this, we can use 2 bits to encode the states such as 00, 01, 10, and 11. In this particular problem, there are 5 states. Thus, we need to use at least 3 bits to encode the states. By the way, for counter systems, in general, we let the output equals to states. For a counter, the outputs are the numbers in the counting sequence, 0, 2, 3, 5, 6, in this particular case. Therefore, we can simply assign the first state as 0, 0, 0 by using 3 bits, and then 0, 1, 0, and then 0, 1, 1, and then 1, 0, 1, and finally 1, 1, 0. Then we come to the remaining 2 questions, which are pretty straightforward. What is the input? What is the external input? And how many bits it is? Of course, clock and reset are also inputs. I think it's better for me to clear everything before we proceed with the discussion. Okay, of course, clock and reset are also inputs, but the term input here refers to the external input. That is, the control input determined by user to decide the sequence of the counter. Obviously, this particular counter has no external input. Let me remove this. So this particular counter has no external input because there is only one path for one state to transition to another. The example of counter with external input is the up-down counter, such as we have 0, 1, 2, 3. And then, for example, if the control input is 1, the counter counts up. And if the control input 0, the counter counts down. Okay, so this is the variable that control the state transition, which is called the external input, or simply the input. All right. And the last question. What is the output and how many bits it is? As I have mentioned before, in general, for a counter, output equals to state for a counter in general. And this is the case for this particular counter. And since the states are 3 bits, the outputs are also 3 bits.